Doesn't seem to want to advance. Okay, so I'm here to talk about OAuth2 based token-based transfers for IceCube. This is something fairly new that we've been doing, but it's designed to get off of grid FTP and onto HTTP-based file transfers. So I'll first give a bit of an overview about how this sort of works and how admins need to configure things so that users can actually use it. Then we're using Nginx for our HTTP-based servers, so I'll cover some of that, and some of IceCube's experience in how this was all worked out. So first, getting a token. OAuth is fairly complex. There's many different stages in here, but here is Condor and the thing that we care about. This is the standard OAuth triangle that if you've seen OAuth before, you know it looks complex, but it's not actually terrible. First, Condor will ask the user to say, get a token. The user's browser will have to pop up, and then the user has to click on the link to their identity provider. This is whatever they want to log in as. This could be Google, this could be something custom, but it has to provide the OAuth semantics. Then when they log in, once they log in, the provider will send their browser a redirect with a code that says, here is your login. You can send this to the HD Condor OAuth app, and it will give you the registration for it and your token. So Condor will then ask the IDP with that code, please give me the correct token, and it will get it and send it back to Condor for all the daemons. This is fairly complex and messy, but hopefully the users will just see one or two redirects and it'll all magically work. Refreshing a token is a little bit easier. You need to refresh the token because the access token only lasts a few minutes usually, versus the refresh token can last hours to days, even months. So it's, but this is fairly streamlined. Condor can do this almost automatically. It has a refresh token and it can just say, hey, give me a new one or give me the access token, and it will then send it back as long as the refresh token lifetime is still valid. Then to get the token to the job, where it actually needs to do file transfers. First, we have a Condor shadow that starts up. It will send the access token to the start D, and the job can use it as necessary. And since the access token only lives for a very short amount of time, it will be repeatedly updated as needed. I think it's every 20 minutes or so. So you can see that when you need to say write the file at the end of the job, the access token will still be valid. One of the reasons why you don't send a longer lived token is in case someone malicious is over here and they can get that token. It's decently hard to revoke these very quickly, but with a short lifetime, the attacker can only use the token for a few minutes and then it's no longer valid. So for some of the administration setup, you have to configure a number of knobs and you have to install a number of things. First, there's this OAuth daemon that needs to be running. You need to run Apache or some other web server in order for the Condor web app to actually get new tokens. So there's this nice RPM that you can install here. This contains most of the necessary tools. It works well if you're on a RHEL system. If you're on Debian, I don't know that it's available, but you can take the pieces out of the RPM that you need. So that there is included an example web app that does basic things. It works well. It just may not be very user-friendly or visible, and you may want to put your own logos on top of it. But you can put that into the Apache web directory, and it will run. Then you have to configure htcondor to tell it about your identity provider and what sort of client you have. So it's this mess here is how to configure Condor as an OAuth client with a nice ID. Then the secret file or the secret that you've registered in the identity provider. The URL to both authorize and to make new tokens. And then this is just a suffix to tell it where to return back when it redirects. As a user, it's still complex, but it's simpler than as the administrator. As long as the administrator does everything right, then it's fairly easy. So the main thing is that you need to tell Condor which IDP you are using. So if the administrator configures multiple of them, you need to tell it, I want this one. Then if your token needs additional scopes, or if you want to use a handle, so that in case you have multiple tokens, you need to specify that. Then you need to use the token in transfers. And the syntax is that you put the IDP identifier in front of the URL with a plus sign. And if you're using a handle, you use the IDP identifier dot and then the handle. And if you're doing input, this works fairly simply. You just use transfer input files. If you're doing output, you need to use the transfer output remaps to tell it where it should actually be sending this file. Then when you actually try to do Condor submit, you need to actually get your token. So the first time, this is what it will look like. It will say, here's this nice URL that you should go click on and open the browser, and it will stop the submit at that point. So you can see here, this is what the standard web app looks like. It's very generic, but all you have to do is click that button and it will take you to your identity provider to log in properly. Then after you've completed the login, Condor will work again if you try to do Condor submit. So you have to do Condor submit twice in order for it to do this properly. We've used Nginx as the HTTP server to handle the data transfers. Nginx is a fairly good HTTP server. It powers like 1/3 of all the websites, so it should be fairly robust. The free version doesn't directly support OAuth2, but it has mechanisms that will allow you to do this. You make a sub request to a server that can actually do the OAuth authentication, which in our case is just a simple Python script that validates the token that is in the header and returns yes or no. This could also evaluate policy. One thing you want to not do is to make external requests to databases because presumably you're going to be getting a lot of these requests. And so you want to make this to be fairly fast. I included a couple links here with our examples. I believe these are all public and they should work. But this, it only validates the token and gets our file system's POSIX IDs from the token. And it doesn't do any other checking, so it's very, very fast to run. Then after that, you need to make Nginx actually read and write as the correct user because it starts not as the user that should be writing. So we found a plugin where Nginx supports Lua scripts, and you can write a very simple one to just run set FSUID and set FSGID. So the Nginx process will become the user, and then it will either read and write properly, or it will fail because the permissions were wrong. So some of IceCube's experience with this. IceCube has Keycloak as an identity provider. We recently have switched to this from LDAP. This stores the source of all truth in user management, and it obviously supports OAuth2 and a couple other protocols as well. So you can see this is our generic login page that users can now log into from any web-based app. IceCube has had a fairly long history with FTP. We've used X509 proxies for data transfer for many years. On production, it works fairly well with this since there's fairly limited number of users and they're fairly steeped in knowing how to use this. Users don't really like X509 or they're confused by it. They don't understand what this complex thing is, mostly because the normal web does not use these. So we're basically going to be transitioning to all these HTTP-based transfers. It's been a fairly long testing phase, and the proof of concept took several months, but we think we're getting close to actually releasing this. So there's been a few bumps along the way. Getting Nginx configured correctly was a bit of a hassle. It seemed simple in principle, and most of the time it worked, but there were a few little things. We needed a specific build with the correct plugins, and it turned out that the Nginx Docker container wouldn't quite do what we wanted, but the base Ubuntu container with several of their packages was actually fairly easy. Then it was how to bake in some of this common config and only override when necessary, since there's a fairly significant block of common Nginx stuff that we don't need to modify every time. As a result, we made a few continuous integration tests and Docker container that correctly tests that what we did is right and passes all of our tests. Another problem we had was the HD Condor curl plugin did not support the OAuth handles properly. Initially, there was an underscore between the IDP and the handle, and it had to be changed to a dot in order to make it a valid URL. This was fixed in 9.0.12. Finally, reusing the tokens in the subsequent job submissions is fairly prone to failure. We're not sure exactly what to do with this, but we're basically going to advise using the handles so that it's unique, and then you don't have this problem. So we've currently deployed this with Kubernetes. So we're using Nginx and the auth sub request as two containers in the pod, and it will auto scale with the load. So that this is somewhat different from a FTP server setup, which was very static and just like, well, we had 3 servers and hopefully that's enough. Plans for the future. So we're going to be rolling this out to users soon with the current content or syntax for now. We may try to hide some of these details with job transforms, depending upon how much the users complain. Production might still need some work. I'm currently looking at how to transfer refresh tokens from our production application to Condor, since they need to talk to each other. And I have several ideas on this, and I just need to put more work into it. And that's all I have.